Right. For this video, what I want to do is go over estimation and rounding. These are very basic concepts, but oftentimes we assume students remember this and a lot of times you don't. So the purpose of this video is to be kind of a quick overview, but to still cover the basics again of estimation and rounding. Okay. I will warn you, I'm on my laptop, which is touchscreen. It can be a little messy, but you'll be able to get the gist of it. So let's go to the whiteboard. Okay. So let me move some stuff around so I have more room. All right, so estimation and rounding. So you see what I mean? It's messy, but you'll be able to get the gist. So estimation and rounding. Okay, so estimation is the process of arriving at an approximate answer to a question, and we use rounding to assist in that process. So estimation is the process of arriving at an approximated or an approximate answer to a question. So again, forgive the messiness of this, okay? You'll get the gist. It's just a little, I don't have a really good stylus for this particular computer. So here we are, okay? Now, the way we estimate is we'll take numbers, okay? We will round them to a particular place value first, and then we'll do the operation. So we round numbers to a particular place value, and then perform operations. So in math, when we talk about operations, we're talking about adding, subtracting, multiplying, dividing. Sometimes we're talking about exponents or square roots. Okay, so what we'll do is we'll take these numbers, we'll round them to a particular place value, and then we'll perform operations on them. That will give us an approximate answer that's usually like really close to, in that ballpark of what the actual answer would be. But by rounding the numbers first, we make them easier to work with. And that's really the gist of estimation. Okay, so let's talk about a few more things just involving numbers in general, and then we'll dive into actually how to round, and then we'll do some practice problems with estimation. Okay, so let's see what's next. Okay, so first of all, we have different types of numbers that you're definitely going to see in this class. We have the natural numbers. I'm trying a different stylus, and I think it's even worse than the first one. So we've got the natural. Gosh, that's even worse than the second one. I'm just going to stick with the original. So we have the natural numbers. Okay, that is not a hashtag, that is a number symbol. So these are also called the counting numbers. Okay. And if you think of counting items, let's say you had a stack of, I don't know, books that you wanted to count. You would start with 1 book, and then 2 books, and then 3 books, and then 4 books. So the counting numbers, or more officially, the natural numbers, start at 1, and then they increment by 1. Okay. So those are called the natural or the counting numbers. Next up, we have the whole numbers. Okay. So the whole numbers are basically the natural numbers, but starting at 0. So 0 plus the natural numbers. So as a set, we would start with 0 and then increment by 1. So those are the whole numbers. Okay. We also have another set of numbers called the integers. We're not going to deal with those when we're talking about rounding. They will come up later. But the integers, I'm not going to give you a definition. I'm just going to show you what the integers look like. The integers are like all of the whole numbers and then all of their negative counterparts. So there's no beginning to the integers. They start at negative infinity. But then you increment by 1 still, so you don't have any decimals or fractions, but you do have those negatives. So you go -3, -2, -1, 0, 1, 2, 3, ... Okay, so the natural numbers, the whole numbers, you're going to see a lot of that in this section. The integers you'll see throughout this course, not so much in this section, but there you have it. Now, next up, we have what's called the rational numbers. Now, the rational numbers are vast, and there's many facets to the rational numbers. I want to make it kind of basic. So this would be any number that can be written as a fraction. And again, you have to forgive my messy handwriting. I promise my handwriting is better than this. It's just this stylus is not great. Okay. So anyway, this is any number that can be written as a fraction. I think I put fractions, but you know what I mean. Let me erase the S. There we go. Okay. This also includes decimals that terminate. I promise that says terminate, but I'll take the time to rewrite this one. So this would be decimals that terminate. That means they just end, or decimals that repeat. So rational numbers could be something like 7. Okay, plain old 7. I could write that as 7/1. Now it's a fraction, even though we started with plain 7. It could be like -2. Again, I can write -2/1 and I have a fraction. It could be something like 3/4. It could be something like 0.92. It could be something like 0.3 repeating. Those are all examples of rational numbers. And the reason I bring this up is because here in just a second, we're going to talk about decimals. Okay, so you get the idea of what these types of numbers are. We have natural numbers, those start at 1 and increment by 1. We have the whole numbers, which start at 0 and increment by 1. We have the integers, which have no start. They technically would say we start at -infinity, but you have the negative and the positive whole numbers and then 0. Then you've got the rational numbers. Those are your fractions, and then the decimals that terminate and repeat. Okay, so let's keep talking about numbers. Okay, if you look at these values right here, these are called digits. So any number that we have is written out and it's composed of different digits. Okay, and we use something called place value indicate. So we use place value to indicate the location of each digit in a number. And so I do want to show you a place value chart. It'll be easier than writing it out, especially since I don't have a stylus that works really great with this touchscreen computer. So let me switch what I'm sharing. Okay, so this is an example of a place value chart. I'll have it available to all my students, but you have a decimal point. Anything before the decimal, those would be your whole numbers. Anything after the decimal point would be the decimal portion of the number. Okay, one thing I do want to tell you, and I'll write this on the whiteboard when we get back to it. Any number after the decimal, the number of digits after the decimal, we call those decimal places. So we could go out 1 decimal place, 2 decimal places, 3 decimal places, 4 decimal places, and so forth. Okay, now notice the place value. We're going to start with the whole number part. Next to the decimal, we have the smallest. That's the ones place. Then we go tens, hundreds. There would be a comma if you have another number. And then we have the thousands, 10,000s, 100,000s, the millions, 10 millions, 100 millions. If we kept going, we would have billions, 10 billions, 100 billions, trillions, 10 trillions, 100 trillions, and so forth. So again, if you're before the decimal, you start at the smallest digit, which is going to be the one closest to the decimal. You work your way to the left, and it's ones, tens, hundreds, comma, thousands, 10,000s, 100,000s, comma, millions, 10 millions, 100 millions, comma, billions, 10 billions, and so forth. Now, after the decimal, it's a little bit different because we're talking about fractional parts of a number. So the first digit after the decimal place is the smallest, or it's not the smallest, it's actually the biggest, and you move to the right. But the first digit after the decimal place is the tenths, and you do have that THS there. Then it's the hundredths, then it's the thousandths, then it's the 10,000ths, the 100,000ths, the millionths. We could go 10 millionths, 100 millionths, billionths. Okay, But basically the decimal separates the whole number part from the fractional decimal part. Starting before the decimal, the smallest digit is closest to the decimal, and then you move left and get bigger. After the decimal, the biggest place value is closest to the decimal, and then you move to the right and you get smaller and smaller. Okay, so you do need to be familiar with place value, because place value is a huge part of rounding, which is what we're going to talk about in just a bit. Okay, so let me go back to the whiteboard. So there's your place value chart. It is something that you need to be pretty well familiar with. Okay, refer to the chart as needed. Okay, so again, place value indicates the location of each digit in the number. Digits after the decimal are called sometimes decimal places. And it's not that the digits are decimal places, it's the number of digits after the decimal indicate the number of decimal places that you have. So if you have 3 digits after the decimal, you've got three decimal places after the decimal is basically what we'd say. So remember the decimal, if you're looking at it, numbers before that, they start small and get bigger as you go to the left. If you have the decimal, after the decimal, the digits start big and get smaller as you go to the right. Okay, so kind of understand how the order of those numbers matters, and definitely make a point to kind of memorize place value, because if you don't know place value, you're not going to be able to do rounding. Okay, so let's talk rounding and then we'll look at some examples. So rounding numbers. Now, the whole point in rounding numbers is you're just seeing what am I closer to? Am I closer to this place value or that place value? Okay, so I'm not going to write out the definitions, but we're going to go over some examples. I'm just going to talk you through it. So when you're looking at rounding numbers, you're going to be given a particular place value. So the directions might say round to the nearest tens place, or round to the hundredths place, or round to the millions place. You need to figure out what digit is in that place value. I like to call that the rounding digit. So you do need to locate the rounding digit by place value. So this is why understanding place value is very, very important. So what happens is we find that rounding digit, and that's the one that's given to us by place value. But the digit that really tells us if we're going to round up or if we're going to round down is the single digit to the right. Okay, so then you want to locate the single digit to the right. Okay, this is going to be the case whether you're rounding whole numbers, whether you're rounding decimals, whether you round up, whether you round down. You find your rounding digit and then you look to the digit to the right. Okay, now rounding up occurs when that digit to the right is 5 or greater. So you locate your rounding digit. Let's say, for example, we're going to take 5,273 and we're going to round it to the nearest 100. Well, I want to locate the digit in the hundreds place, which is the 2. But most importantly, I'm really looking at the 7, because the 7 tells me if I'm going to round up or down. If this digit to the right is 5 or greater, I round up. Well, it's 7, so that's greater than 5. So I round up. And the way I round up is I add 1 to the rounding digit, and then everything after that just becomes zeros. So we would say 5,273 is closer to 5,300 than it is to 5,200. And that's the whole idea of rounding. What am I closer to based on a particular place value? Okay. Now, rounding down, what you would do, let's say we have 17,139. Okay. And let's say I want to round to the nearest 1,000. Okay. So the first thing I want to do is locate my rounding digit. That's the one that is given to you by place value. So that would be the 7 here. I'm going to look 1 digit to the right. If that digit is less than 5, I round down. And the way we round down is we don't do anything to the rounding digit at all. So we would leave the 7 alone, and then everything after that would become zeros. So that tells me if I'm rounding to the thousands place, that 17,139 is closer to 17,000 than it is to 18,000. Okay. Now, as far as decimals are concerned, it can be a little bit different. So let's say we have 4.973 0.63, and I want to round to the nearest hundredth. So look for that THS, and you know you're after the decimal place. Okay, so I locate my rounding digit, which is the 7. I look one digit to the right of that, and I have a 6, which is 5 or greater. So that means I'm going to add 1 to the 7, but instead of making everything after the 7 zeros, if I'm dealing with rounding after the decimal place, I just chop those zeros off. So I would say this is 4.98. And one thing you'll see pretty much all the time when you're rounding is you'll see this like wiggly equal sign. That wiggly equal sign just means approximately equal to, and you use that anytime you're rounding. Okay, so just to kind of recap really quick, when you're rounding numbers, you want to locate the rounding digit by place value. The most important digit is really the one to the right of that. It tells you whether you round up or down. If that digit to the right of the rounding digit is 5 or greater, you add 1 to the rounding digit. Everything after that either becomes a 0 if you're rounding before the decimal place. If you're rounding after the decimal place, everything after the rounding digit becomes, just gets kind of chopped off. Now, when you round down, you do the same thing. You find your rounding digit, you look to the digit to the right. If that digit is less than 5, you round down. That means you do nothing to the rounding digit, and everything after that becomes zeros. Or again, if you're rounding after the decimal place, you just chop off all the digits after the rounding digit. Okay, so those are the basics. Let's look at some examples. Okay, so there's an example about at one point the world population was this. Now, I don't think this is still the world population, but at some point in time, this is the world population, which was 7,476,242,056 people. And what we want to do is round this first to the nearest billion. And then second, we're going to round this to the nearest 10 million. So let's look at the billions place first. So we've got first, starting with the 6, we're in the ones place, then the tens place, then the hundreds place, then we got a comma, thousands, 10,000s, 100,000s, comma, millions, 10 millions, 100 millions, comma, and then we have the billions. So the 7 is in the billions place, but we're going to look one digit to the right of that, which is a 4. Now remember the rules. If the digit to the right of the rounding digit is 5 or greater, you round up. If it's less than 5, you round down. In this case, we would round down. That means the rounding digit stays the same. And then everything after that, because we're rounding a whole number, it just becomes zeros. So at this time, the population on Earth was approximately 7 billion people. It was closer to 7 billion than it was to 8 billion. Okay. Now, next up, let me erase a couple little marks. Next up, let's look at rounding to the nearest 10 million. So again, starting at the right, we've got the 6, which is in the ones place, then tens, then hundreds, comma, thousands, 10,000s, 100,000s, comma, millions, 10 millions. So the other 7 is in the 10 millions place. But this time, the digit to the right is a 6, which is greater than 5. That tells me I'm going to round up. So my rounding digit, I'm going to add 1 to it. So the original 7 and 4 stay the same. The rounding digit was a 7. It now becomes an 8. And then everything after that becomes a 0. So in this particular case, the world population was closer to 7,480,000,000 than it was to 7,470,000,000. Okay, so that's rounding in a nutshell. Let's look at a decimal example. Okay, so hopefully most of you are at least somewhat familiar with pi. We're going to look at the first several digits. So we're going to look at it like this: 3.1415925, and we're going to round this to the nearest 10th. And then we are going to round this to the nearest 10,000th. Do be careful if you're rounding after the decimal place. The place value ends with the TH or the THS. So just be really careful and don't get mixed up with before the decimal versus after the decimal. All right, so looking at the nearest 10th, after the decimal place, the first digit is in the 10ths place. We're going to look one digit to the right of that, which is a 4. That's less than 5. So that tells us to round down. That means we leave the rounding digit alone. The 1 stays a 1. And then because we're rounding after the decimal place, instead of adding a string of zeros, we're just going to chop everything after the rounding digit off. So we would say pi rounded to the nearest tenth is closer to 3.1 than it is to 3.2. All right. Next example, we're going to go to the 10,000ths place. Let me erase my marks. So we have, starting with the digit after the decimal, the 1, we've got the tenths, the hundredths, the thousandths, then the 10,000ths. So the 5, that first 5 is in the 10,000ths place. We look 1 digit to the right where we have a 9. That 9 is certainly greater than 5, so we round up. That means we add 1 to the rounding digit. And then after that, we just chop everything off. So we're going to get approximately 3.141. Everything before the rounding digit just stays the same. The 5 becomes a 6, and then we chop everything after that off. So this pi rounded to the nearest 10,000ths is closer to 3.1416 than it is to 3.1415. All right. And that's rounding decimals and whole numbers. All right. So let's look at a couple of other examples. So we have an example where you and a friend ate lunch at your favorite cafe. Okay. The check for the meal showed that you have soup for $3.40. You had tomato juice. I'm just going to kind of shorten it for the sake of, I've got a crappy stylist. So you got tomato juice for $2.25. You got a roast beef sandwich for $5.60. You've got chicken salad. I think it's a sandwich again. And we're going to get it for $5.40. We're going to get 2 coffees. And this is kind of tricky. You do have to be careful. The 2 coffees total $3.40. It's not that each coffee is $3.40. The combined cost for both of them is $3.40. You're going to get apple pie for $2.85. And then finally, chocolate cake. And I'm going to kind of abbreviate it because, again, my stylus is garbage. Okay, for $3.95. Okay, so here's what we're going to do. For part A, it says round the cost of each item to the nearest dollar. So that's going to be what's in technically the ones place. We're going to round each item to the nearest dollar and then get an estimate for the food bill. Okay, so if I have $3.40, I'm looking at this 4. That's going to tell me if I round up or down. 4 is less than 5. I do nothing to the rounding digit. So we're going to say the soup is approximately $3. Okay, the tomato juice, again, we're going to look at this first digit that's in the 10ths place. That's going to tell us if we round up or down. Rounding to the nearest dollar, this 2 is less than 5. I'm going to round down. We're going to say the tomato juice is approximately $2. The roast beef sandwich, this time, the 10ths place is a 6. That's greater than 5. That tells me to round up. So this roast beef sandwich is closer to $6 than it is to $5. What's next? Chicken salad sandwich. If we look at the 10ths place, we've got a 4. That's less than 5. It tells me to round down. So the chicken salad sandwich is closer to $5 than it is to $6. The coffees, we're looking at the 10ths place. Okay, that's less than 5. That tells me to round down. So in the dollars place, it's going to be a 3. So these coffees are closer to $3 than $4. The apple pie, my rounding digit is that 2, but the one that's really important is the one in the 10ths place that tells me to round up or down. So in this case, I'm going to round up. That means this apple pie is closer to $3. I'm going to add 1 to the rounding digit. So I'm closer to $3 than $2. And then the chocolate cake, again, the rounding digit's the 3, but the one that really matters is the 9. That tells me to round up. So the chocolate cake is closer to $4 than it is to $3. And now what this does is this is easy to do mental math. And that's the whole point of estimation. You're rounding these numbers to a particular place value. Then you're going to perform some operation on them so that you can get an estimated value or an approximate answer. So if we go through and add, we have 3 plus 2, which is 5. 5 plus 6 is 11. 11 plus 5 is 16. 16 plus 3 is 19. 19 plus 3 is 22. 22 plus 4 is 26. So if we round all of these values to the nearest dollar and then do a quick mental math on them, we get that the bill is approximately $26. Okay. So that's kind of part A of this example. The second part says that the total bill before tax was actually $29.85. Is this amount reasonable? So the actual amount, like if we just took out a calculator and added $3.40 to $2.25 and so forth down the list, we would have gotten $29 and what did I say? 85 cents. So this is the actual value. This is the estimate. What we want to know is the estimate reasonable? Well, in this case, not really. So if you did this estimate rounding everything to the nearest dollar and you're like, oh, our bill's going to be $26, you'd end up almost $4 short. So in this case, the estimate is definitely an underestimate. It underestimates the actual value by quite a bit. Okay. So in this case, the estimate not going to be a great one. Okay. Let's look at one more example just for practice. Okay, so the last example, we have a landscape architect works full-time making $52 per hour. So we have a landscape architect and they make $52 per hour. Again, apologies for the messy writing. Okay, I need a little bit of water. Hold on. Okay, so this landscape architect, they make $52 an hour. The first thing we want to do is estimate the weekly salary. Well, for most full-time workers, a week is 40 hours. So what we would do is we want to take the $52 and we're going to say it's approximately $50. We're going to round to the nearest 10. Okay, that's going to give us an estimate for his hourly rate. And then we're going to multiply that by 40 hours per week. And that's going to tell us that this particular person makes approximately, I do want to use, let me go ahead and erase that. I do want to use the approximately equal to. So this particular employee makes approximately $2,000 a week. Okay, so the next thing we want to do is estimate the annual salary. Okay, so we have 52 weeks in a year, but let's do the same thing. Let's round that to the nearest 10. So that's going to be approximately 50 weeks, making $2,000 a week. So this particular employee makes approximately $100,000 per year. Now let's talk about, is this a good estimate or is this a bad estimate? Okay, so I'm going to go to the next screen. So the actual weekly salary would be $52 an hour times 40 hours a week, which would give us $2,080 per year, or per week, sorry. The actual annual salary would be, well, there are 52 weeks in the year. Each of those weeks, this particular employee is making $2,080. Trust the math here. I used a calculator. Okay, so this particular employee would be making $108,160. So the question is, was the previous estimate a good estimate or not? Well, if you're looking at $2,000 a week, 2,000 and 2,080, that's a decent estimate, okay? Because they're far enough apart. It's not a perfect estimate. It's an underestimate, but in this case, underestimating your salary, not that bad, because the benefit is this guy or girl, whoever, is actually bringing home a little bit more each week. And then if we compare the annual salary, well, this particular employee is making $100,000 a year estimate, but the actual is quite a bit more than that. So again, if you're out there looking and you're like, I need to be making $100,000 a year, that estimate would be great because you're actually going to make more than that. So in this case, an underestimate's not the worst thing ever because the reality is better. Whereas that previous example, if we underestimate, then we don't have enough money for our meal. Okay. Now, neither of these estimates, the meal or the architect's salary, are exact. Okay. But it kind of depends on the situation and comparison. You know, again, if you're dealing with, 20, 30 bucks. If you're off by 4 or 5, that's a good bit. If you're talking thousands and thousands of dollars and you're off by 80 bucks or 8,000, that's not quite as big a deal. In this case, both estimates were off. They weren't super duper close, but that's the general gist of estimation. So again, if we go way back to the beginning of this chat, we have that estimation is the process of arriving at an approximate answer to a question. And what we do is we round numbers to a particular place value and then perform operations. That whole process of rounding the numbers to a particular place value, what it does is it makes the math easier. And so you are getting an approximate answer, as you can see here. Okay, but the math to get there was a little bit easier than adding up the actual values. Okay, so that's estimation and rounding. It's not the hardest thing you're ever going to see. I will say it's one of those things that as instructors, we assume students remember this, but then oftentimes we get into the classroom and the students have forgotten this. Okay, it's not something that's really, really hard to bring back to the surface, but it is something that you need to take some time, study, practice, and bring it back to the surface because it's going to come out throughout this course. All right, so that's estimation and rounding. If you have questions, let me know.